Hello, I'm Roy Tomolino with Beamex. During this short video, I'll show you how to calibrate a temperature loop consisting of a temperature element and a temperature transmitter. Let's start off with what we have on the table. We have a Beamex FB150 temperature block. We have a Beamex MC6 calibrator. We have the temperature element under test along with our temperature transmitter. This one happens to be a Foundation Fieldbus, but it could easily be a Profibus or a Hart or even a standard conventional transmitter. Now the dry block, we've added an RPRT, a highly accurate temperature probe, to increase our accuracy by about 10 times. The calibrator is providing loop power to our transmitter as well as measuring our Foundation Fieldbus signal. We're controlling the dry block with our MC6 calibrator using this USB cable. The USB is going through a converter to a serial cable connecting to the front of the dry block. Let's get started. We'll start off with documenting calibrator. We already have this position or tag loaded into the calibrator. It's called TT878-FF. So we just select it. As a technician, you're out in the field, your goal is to calibrate this loop. So you select the tag and then you are shown how to connect. So on the very bottom we can see that we'll connect the Fieldbus signal right here, and that's also where we'll get our loop power. And it's showing us that for our input, we're connected here via USB, and that's connecting over to our dry block. And we can see the communication happening with our USB to serial converter. One light is to transmit and the other one is to receive, so that's how it's talking right now. Press a check mark to get started, and then we simply hit start. The temperature block is driving to our first test point, which happens to be 0 degrees C. We've reached our first set point, and we have a predefined set point delay of 15 seconds, which is counting down at the bottom. As soon as it reaches 0, it will grab that test point and move on to the next. Right now, the temperature block is heating up for our second test point. While it's doing that, let me explain what's going on with the screen. On the upper left hand, we have our input. This is the actual value coming from our highly accurate reference probe right here. The output happens to be the output of the Fieldbus transmitter. We have a live reading of the error right above the graph on the right-hand side. It gives you a live reading, and there tends to be some lag between the temperature element and then the output of the transmitter. With the graph, this middle point is our 0. So if our dots line up along the 0, we have no error. We have a predefined error tolerance, and that is signified by the blue dashed lines. We have an error tolerance set up of 0.5% of span. We've reached our second test point of 50 degrees. The calibrator will grab that test data and tell the dry block to move on to the next test point. You can see here on the bottom right, that tells us where the calibrator is going. So it's pushing us towards 100 degrees C, and it also says that we're expecting 100 degrees on the output as well. We've reached the final test point. As you can see, the dot is a little bit below on the graph. We can see our error tolerance. We're at negative 0.182% of span error. Once we get the final test point, then we show that it is passed. At the bottom, we can see our maximum error. We can cycle through the screens and we can put in extra notes if we need to that pertain to the calibration record. And we can see what our graph looks like as well as the raw data. If we hit down again, it simply cycles back around. But let's save this test. And this was an as found test and it did pass, so let's go ahead and hit the check mark. At this point, our data is saved. We could power this down and take it back to the instrument shop if we needed to, or maybe head over to the next device that we needed to test. But you could transfer the data, the numbers, to another entry system, or you could simply unload it directly into our CMX calibration software, never having to write down a number, all electronic. So what you've seen is an automatic calibration of a temperature loop using an MC6 and an FB150. All we did was press the start button and it ran through all of our temperature ranges, grabbed all of the test points, did the calculations. Now during that time, you could have done something else. You could have maybe installed the last temperature element that you just tested, or maybe went out to grab the next one on your list. But either way, this calibrates whether you're here or not. So now you've seen how to do an automatic calibration of a temperature loop. For more insight on demystifying calibration, check out our other videos. Thanks for watching.